and second smallest will be 2. So these two will be complementary to each other. So let's take a smaller number, not 600, because I will have to write many factors here. So let's reduce the exercise with by taking 60. So I'll be writing these two again. So the next set will be, and I should have written in this way, that 1 into 60, 2 into 30, 3 into 20, 4 into 15, 5 into 12, and 6 into 10. So there are few things to observe here, that every factor has its complementary factor, which makes, or by multiplying with that, you will get the original number n. So 60 has a factor of 60 only if 1 is also the factor of 60. 60 has a factor of 30 if 2 is also the factor of 30, because 2 into 30. So how many factors are there in here? So we have 6 pairs. That means 6 into 2, 12 factors. So I'll not just cover LCM SCF, I'll be also covering some of the other important thing here, or important part of numbers. So let's take another number, 36. And just tell me all the factors of 36, like I have written here for 60. फटाफट बोलते चले जाओ. Anyone can make that effort. Tell Tarun. 1 into 36.
2 into 18.
2 into 18. Next.
3 into 13.
3 into 12, na?
12. Sorry, 12.
12. Next.
4.
4 and 9.
4 into 9. And then
6 into 6.
6 into 6. Good.
6 into 6.
So I cannot go beyond that. It will start getting repeated. So what do you see here? That if I want to know the total number of factors, I have exactly 4 pairs. And 6 is the only factor which doesn't have any other complementary, but 6 is the complementary, the same number is the complementary. So the total number of factors are 4 pairs and 1. That means 9. So you can just see the pattern that all the numbers, and why we are getting one single factor, or a factor which doesn't have any complementary, because 36 is a perfect square. 36 is a perfect square. So this is a very important observation. So if I am writing here, let's say I am writing a number 144. And I am also giving you that X factor. 144 has X factor. So X is an even number or odd number? Tell me. The question is, if X is the total number of factors of 144, what we can say about X, whether it is an even number or odd number?
Odd.
Odd. Why? Because
It is a perfect
144,
square.
yes, 144 is a perfect square. That means all the pairs, it will have few pairs of factors, and there will be one factor which will come alone. And then I have 12 into 12. So what you can see here is, there are this much of pair, 1, 2, 3, 4, 5, 6, 7, 7 pairs, and one single factor, which is 12. 15 factors are there. So all the number which exist on earth will have even number of pairs except perfect squares. So only perfect square numbers will have odd number of factors. Did everyone get that? Only perfect square numbers will have odd number of factors. Okay. So this is what you know now. Now let's say I'm writing all the factors of 60 in ascending order. So what I'll write? बोलते चलो, please contribute in the class. And I'm writing all the factors of 60 in ascending order. The first number that I'll be writing here is what? The first number will be
So 1.
1, then 2, then 3, 4, 5, 6, 10, 12, 15, 20, 30, 60. And what I know, and let me write it for 36 also. Let me write all the factors of 36 in ascending order. 1, 2, 3, 4, 6, 9, 12, 18, and 36. So since 36 has odd number of factors, so 6 will lie in between those factors. Now, what you can see here is there are exactly 4 factors which are less than 6 and exactly 4 factors which are greater than 6. Okay. And here in 60, since there are even number of factors, okay, even number of factors. So what is the root of 60? Can anybody tell me what is the approximate value of root 60 is? 7 point something. So 49 has a root of 7 and 64 has a root of 8. So 60 root 60 will be 7 point something, which will lie in between 6 and 10. So what we can see here is exactly half of the roots, half of the factors will lie below the root and half of the factors will lie above the root. And one more thing to observe here is one below the root and one above the root will be a complementary pair. So this is how we get the complementary pairs of factors of 60. So tell me, if I'll ask you a question, median of all factors of 36. What will be the answer?
6.
What is median? Median is the middle value. When you write all the values in ascending order, whatever the value will come in middle, that will be the median. So for 36, all the factors of 36, median of factors of 36 will be 6 only. So if I'll ask the question again, median of all the factors 400. Batao, what will be the median of all the factors of 400?
20.
20. Why? Because you know that 400 will have odd number of factors. And since 400 is a perfect square, all the factor will either less than 20 or greater than 20, or 20 will lie in between them. So the median of all the factors of 400 will be 20 only. So this is how we can visualize factors. You know? The next learning here is in finding prime number, how you can use this concept in finding prime number. So let's say if somebody is asking you whether 181 is a prime or not. Okay, if somebody asked you this question. So what I know that 181 will definitely have two factors. So every number, even it is a prime, will have two factors, definitely two factors, minimum two factors, which is one and its number, the number itself. So 181 will have 1 and 181 as factors, which we are very sure of. Now 181 will be a prime number if there is no factor other than these two. And 181 will not be a prime number if we can able to if we are able to find any other factor other than 1 and 181. So the first thing that I'll be checking is whether 181 is a perfect square or not. So what will be the approximate value of root 181? Can anybody tell? So what you know is 13 square, 169. The root of 169 is 13 and root of 196 is 14. So root of 181 will be in between that 13 point something. So now I know that 181 is not a perfect perfect square. So 181 will not have any factor which is coming alone or without complementary. So if 181 has any other factor than 1 and 181, it will always come in pair, and one of these pair will be less than this and other one will be greater than 13.x. So what now? The problem is reduced to what? You just have to check whether 181 is divisible by the problem is being reduced to whether 181 is being divisible or 181 is divisible by all the prime below this figure. So you have to just check 2, 3, 5, 7, 11 and 13. So you just have to check with these three. You don't have to check other than these, because if it is being divided by any of these here, it will always have a two factor, which is second factor, which is above 13.x. So now I can check that 181 is not divisible by 2, not divisible by 3, not divisible by 5, not divisible by 7, not divisible by 11, not divisible by 13. So now we can say that 181 is a prime number. 181 is a prime number. So now let me ask you a question. If someone is asking you to check whether 1601 is a prime or not. So what will be our strategy? I know that 1 and 1601 are definitely the two factors of 1601. And 1601 will be a prime only if there are no other factors than these two. And it is not prime if we are able to find any other pair of factors. So what will be our strategy? First of all, what we will check whether 1601 is a perfect square or not. So since 1600, root 1600 is 40. So the square of 41 will be much bigger than 1601. So now I know that the root of 161 is 1601 is 40 point something. I'm just writing it something, rather I can write anything here. 40 point something. So to check whether 1601 is a prime or not, how much numbers we do have to check? Tell me. We do have to check with how many numbers? All the prime below 40. Just tell me all the prime below 40. Anyone can make the word? Sanju, can you tell all the prime below 40?
1,
1
3.
is not a prime number. See, remember this. 1 is not a prime number. 1 is not a even number. 1 is, of course, an odd number. But 1 is not a prime number. The first prime number and the only even prime number is 2. Next.
3,
3. Next.
5,
Next.
7,
7. Next.
11,
बोलते चले जाओ. Just keep on telling.
13, 17, 23,
19. And then 23. Next. So just keep it as an homework. Everybody needs to write all the prime numbers below 100. And remember, it should be 25. So there are 25 prime numbers below 100. Okay. But you don't have to reach till 100. You have to just check till 40. 31, 37. Anna. You have to check whether.
Excuse me, sir.
Tell me.
Sir, why do we only check with prime numbers and why don't we include perfect squares?
Very good question. So if we'll see, if the number is getting divided by any composite number, like let's say 6. So if it is divided by 6, it will be getting divided by 2 and 3 also.
Yes,
Rachita?
sir.
Now,
Yes, sir. Got
are you
it.
getting the feeling? So if any
Yes,
number,
sir. Yes.
if any number is getting divided by 15, it must be divisible by 3 and 5.
Yes, sir. Got it. Thank you, sir.
Okay. So if any of these number divides 1601, then I'll have a 2 pair of prime, matlab 2 pair of factors. Now, since I have already done this question and already checked 1601, 1601 is a prime number. Okay. So this is how you check prime number. Okay. So now you learned one thing, that how do we write the factor of any number? So we have 3 important observations, that all the number will have even number of factors except perfect square. And we can easily check that whether a number is prime or not. And second, that we can easily find the median of all the factors of perfect squares. Okay. So these are the few things that we learned now. We'll be moving with other concept, which is prime factorization. Okay. So this particular thing is related to factor only. That's why I'm writing it here. Or discussing the same concept right now. So I took the number 60 before, and I got 12 factors. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. And I was talking about prime factorization, which is, you all know about prime factorization. We need to find how many 2s and how many 3s and how many 5 and how many prime numbers are there. So this is how we used to calculate prime factorization or find prime factorization of any number. So 60 can be written as 2 square into 3 into 5. So there are other way to write prime factorization. Like if you want to write the prime factors of 4200 or the prime factorization of 4200. So what I know, that 10 is being made by 2.2 into 5. Then second 0 is also being made by 2 into 5. 42 is being made by 6 into 7, and 6 can be made from 2 into 3. So now we have 3 2's, so 2 cube, 1 3, 2 5, and 1 7. So the prime factorization of 4200 is this. So in any of such way, you can write the prime factors of any number. You should start doing practice how to write prime factors very fast, or do prime factorization very fast. So the reason why I did prime factorization here, because I wanted to tell you that 60 has been made by 3 primes. 60 has been made by 3 primes. One is 2, one is 3, one is 5. The powers are different, but the prime are 3, 2, 3, 5. So a basic observation or basic common sense will say that all the factors of 60, and even the factors of 60 will be made from 2, 3, or 5 only. I mean, there will be no factor of 60, factor of 60 will have 7 as its factor. The factor of factor. The factor of factor will not, the 7 will not be the factor of factor. Neither you will get 11 nor 13 or nor any prime number. So the point here, the observational, the key point to remember here is all the factor of 60 will be made from 2, 3, or 5 only. Now let's write all the factor by using these 3 factors, by prime, using these 3 factors. So 1 can be written as 2 to the power 0, 3 to the power 0, and 5 to the power 0. 2 can be written as 2 to the power 1, 3 to the power 0, 5 to the power 0. And similarly, we can keep on writing. 6 can be written as 2 to the power 1, 3 to the power 1, and 5 to the power 0. Similarly, you can write 30 as 2 to the power 1, 3 to the power 1, and 5 to the power 1. So what you can see here is that all the factors can be written with the help of these 3 primes and their allowed powers, because none of the factor will have 2 cube as its prime factor. The maximum power of 2 will be 2 only. So now we can easily write here that all the factors of 60 can be made by 2, 3, and 5. And the allowed power of 2 is 0, 1, 2. 3, for 3 it will be 0 and 1. These are the prime numbers. So let me cover it by rectangles there. And 5, allowed power of 5 will be 0 and 1. And if we take any combination of these 3, you will be getting a factor of 60. So let's say if we are taking 2, 0, and 1, the factor will be what? 2 to the power 2, 3 to the power 0, and 5 to the power 1. The number that I'll be getting is 20, which is a factor of 60. So what you can see here is that any combination of these 3 will give you a factor. So how many combination can be prepared? So it will be 3 into 2 into 2. So here we can take any of these 3, here we can take any of these 2, and from here you can take any of these 2. So the total number of 60 will be 3 into 2 into 2, which is 12. Which we have already counted that there are 6 pair of factors. for 60. So now you can observe that how we can actually calculate the number of factors for any number if we are given with there, or we can calculate, or we can find the prime factorization of that number. So let's take another number. Let's take 3600. Okay. So how many factor of 3600 are there? So the first of all, I'll be doing it, or I'll be prime factorizing it. So you know what way I do. Every zero has been made with 2 into 5. So this zero has also been made with 2 into 5. 36 is can be divided into two parts, 4 into 9. And then it is 2 square into 3 square. So the composite prime factorization of 3600 is 2 to the power 4, 3 square, and 5 to the power 2. So now tell me total number of factors for 3600 कितना होगा? Number of factors for 3600. So you know that all the factors of 3600 will be made from 2, 3, and 5 only. The allowed power for 3, 2 is 0, 1, 2, 3, 4. Allowed power for 3 is 0, 1, 2. Allowed power for 5 is 0, 1, 2. So if we take any of these combination, I'll be having a factor. Total number of combination that can be created 5 into 3 into 3, which is 45. And now just check, it is odd. Why it is odd? Because 3600 was a perfect square number. Okay. So here we are mainly concerned with total number of factors of 3600. Okay. So is it fine for everyone?
Yes, sir.
Yes, sir.
Very good. So now let's go for another thing. So I'll be giving you a very good exercise right now. Half of that I'll be doing it in class. Half you can do it in do it as an homework. So tell me, if a number has just one factor, what kind of number that will be?
Prime number.
What? Just tell me.
So
Prime
what
numbers
fact?
have two factors.
Oh,
If a number has just one factor, what kind of that number will be? Only kind is 1. Only 1 has a factor 1. One factor. The 1 has a factor 1, which is just one factor. Are you getting my point here? Did you get the statement? Only 1 has one factor, which is 1 only. Only number, or let me write it in another word. Only number which has just one factor is 1. And the factor is 1 only. Okay? So let's not get confused with this statement. Everybody knows that. Is it clear for everyone?
Yes, sir.
Very good. Now the next part is What kind of number will have two factors? So before we
Prime
delve,
numbers.
so before we go into this exercise, just tell me. I was telling you that we can do the prime factorization. So a number n has a prime factorization p to the power 3, q to the power 4, and r to the power 7. So how many factors of n will be? Number of factors of n. So this is how we represent prime factors, prime numbers, p, q, r. Okay. So p, q, r, s, t, u, v, all these are the prime numbers, representation of prime numbers. So if a number is being represented as this, considering that PQR is a prime number, total number of factors will be 4 into 5 into 8. Okay. So did everyone get that?
Yes, sir.
I just the generalized statement or generalized way of using representing prime. So now tell me that what kind of numbers will have two factors? What kind of numbers will have two factors? Anyone try? What kind of number will have two factor? Which number has two factors? Rachita,
All
Priyamvada,
numbers.
all the prime number will have two factors. Now all the prime numbers. And it can be represented as P. So any P is there, any prime number, any generalized prime number is there, it will have two factors. P can be 2, P can be 3, P can be 5, P can be 11, P can be 7, P can be anything, any prime. Okay. So all the prime will have two factors. Now tell me what kind of numbers will have three factors? What kind of numbers? I'm talking about kind. Matlab, how you can represent, how you can visualize that number which has three factors. Tell me. What kind of numbers will have
Multiple of two prime numbers.
not multiple of two prime number? Any
Square
prime
numbers.
square, any
Square
prime
of a prime
square
number.
will have three factors. Just check like 2 square. No, 2 square is 4. The factors of 4 are 1, 2, and 4. 7 square is 49. The factors of 49 are 1, 7, and 49. You know that only 7 or only perfect square, perfect root comes alone. And if it is prime, then it will come alone only. And 149 will be other two factors. So all the prime square will have two factors. And even with our model of finding number of factors, if p square is a number, the total option of prime factors, total option of factors are p0, p1, and p2. Now, these are the factors. Like in the case of 7, in the case of 49, all the factors were 70, 7 to the power 1, and 7 square. So every square of prime number will have three factors. Now tell me what kind of number will have four factors? What kind of number will have four factors? Anyone?
Every other number than prime numbers, like non-prime numbers.
No. There may be just like 60. 60 had 12 factors. So how you can visualize a number which has just 4 factors?
The cube of a
Cube
prime
of
number.
prime number.
Yes, very good. One of such kind is cube of prime numbers. So any prime which has a cube, so all the factors will be p0, p to the power 1, p to the power 2, p to the power 3. Okay, just let me simplify for many other students. All those people who are just preparing for COQP 11, this might not be very important. So I'm just, while I teach, I try to cover concepts for everyone. While problem solving, you can choose not to solve these problems. Okay. So if you are enjoying the class, just stay here. If you are not enjoying, you can watch the lecture ahead after that class also. But I think you should enjoy because the way I'm teaching, it is very like story kind of thing. Huh? Are you people liking this class? Anyone who have any
Yes,
problem
sir.
with the class? Basically, let me pause the recording. So you were right. All the cube of prime numbers will have 4 factors like this. I can also take an example of cube of 2. The cube of 2 is 8, and all the factors of 8 is 1, 2, 4, and 8. 4 factors are there, which is 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3. All these factors are there. Is there any other way to visualize a number which has 4 factors? Hello. Is there any way in which we can visualize a number which has 4 factors? Sorry, 4 factors. It will be multiplication of 2 primes, p into q. Let's take a number 2 into 3. So what it is basically 2 to the power 1 and 3 to the power 1. So available option for power of 2 is 0, 1. Available option for power of 3 is 0, 1. So the total number of factors which we can make is 2 into 2, which is 4. So any such figure or any such number which we are getting by multiplying 2 prime will have 4 factor. And the 4 factor will be written as, you can write these 4 factor as 1, p, q, and pq. Like in 6, all the 4 factors are 1, 2, 3, and 6. Okay, did you understand that?
Yes, sir.
So
Yes, sir.
I'll tell you, there was a CAT question last year that till 50, it is a CAT question. I just told you the concept, and now it was a question in CAT 2024. Sorry, CAT 2023. I don't remember the slot or the question number. How many numbers have 4 factors and are below 50? So the question is, how many numbers have 4 factors and the number lies below 50? So this was the question of CAT. Now from the previous example, you know, all the four factors number we can visualize as either p cube or p into q. So the number as 2 cube, which is 8, 3 cube, which is 27, and I just have to take the prime only. 5q will be 125, which you cannot take because number should be less than 50. So here I am getting 2. All the numbers which are in this structure will be, let's take the first prime as 2. The second prime will be either 3 or 5, 7, 11, 13, 17, 19, 23, 20, not 29. It should be less. If I take 29, 29 into 2 will be greater than 50. So we have this much of numbers with 2. Then I'll take the first prime as a 3. And I'll not write 2 here because 2 into 3 has already been covered. So I'll start with 5, 7, 11, 13. And I'll not write 17 because 17 into 3 will be 51. Then I'll use 5. The first number that I'll be getting 5 into 7. And I'll not write 11 because with 11 I'll be getting 55. So this is all. So the total number are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sorry, 13. 13. These are the 13 number and 2 these. Did I miss anything? No, I think it's okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and these two. 2 plus 13. Total 15 numbers are there, which has 4 factor and less than 50. So this is how you use your concept in solving questions, okay? So did you get that point? Everyone who's willing to appear for CAT, now you can find that how concepts help in solving questions. Okay, Priyambada, Yaskant.
Yes, sir.
And, so next, next we can also visualize it for 5 factors. How many or what kind of numbers will have 5 factors? How we can visualize 5 factors? P to the power 4. There is no other way to visualize 5 factors. How we can visualize 6 factors? So it is either P to the power 5, the 5th power of prime, or P square cube. This will have 3 into 2, 6 factors. So this is how we can visualize a number with the help of number of factors of that number. Okay. Now, one important thing that I missed there, I took an example of 3600. Let's say I have a number again. 3600 is the number. And the prime factorization of this number is 2 to the power 4 into 3 square into 5 square. And total number of factors that can, which is there for 3600 is 5 into 3 into 3, 45. Now, out of these 45, how many factors will be odd factors? How many factors will be even factors? And how many factors will be square factors? Number of, there are 3 important questions related to this. Number of even factors, number of odd factors, number of square factors. If you want to calculate these three figures, okay? So what I know right till now is any factor of 3600 can be made through 2, 3, and 5 only. And the required power or allowed power is these for 2, these for 3, and these for 5. So what I know, to get an even factor, I must have 2 in that. So if it neglect the 0, if I'll not use 0, and if there is a mandatory to use 4, use 2, any power of 2, then total number of combinations of factors that we can have is combination of these we can get is 4 into 3 into 3. So these are the total number of even factors. If you want to get odd factor, you should ignore all the 2. There should not be 2. So only allowed power is 0. So for 2, it is 1 only, and you don't have anything, you don't have to do anything with the 3 and 5. So total number of odd factors are 9. You can just check 36 plus 9 is 45, which is total number of factors. And if you want to find total number of square factors, then we have to take just even power of factors like 0, 2, and 4. For 3 also 0 and 2. For 5 also 0 and 2. So the allowed powers which we need to use for getting in a square factor is 3 into 3, 2 into 2. So the total number of even factors, square factors are so did you understand that?
सर ये ऑड फैक्टर्स वाला नहीं समझ रहा हूँ.
देखो ऑड में क्या था कि आपको 2 का कोई भी पावर नहीं लेना है, 1, 2, 3, 4 नहीं लेना है, क्योंकि एक भी बार 2 आएगा तो इवन हो जाएगा. समझ में आई मेरी बात? बोलो.